Okay. So, hi everyone. Nice to see you here today again in our next coffee break. So today we are talking about carbon farming and the price of it, not only for the nature, but also for our own of our own farmers' money. How much does it cost, and what are the good things and maybe not so good things about it? So yeah, today our invited speaker is Štěpán Krejčí from Agricultural Research Institute Trobsko from Czechoslovakia, from Czechia. I'm so sorry, yeah, as always. I will inform you about the terms of the event. So basically, all this presentation will be presented by Štěpán. So there will be one longer presentation. So for you not to forget your questions, please put them in the chat, and you will be also asked to ask your questions after that presentation. Today we have quite a lot of registrations. Let's see how many will come face to face. But yeah, today we have 106 registrations from 28 countries, and I guess that just means that this thematic is very, very actual for people around Europe and not only. So Štěpán, please be your guest, and you're welcome to present. Your mic is not working.
Okay, you can hear me now?
Yeah, perfect.
Okay. Thank you, Anita. Good morning, everyone. Thank you for joining us. Welcome also from my side. As you've heard, my name is Štěpán Krejčí, and I'm from the Agricultural Research in Trobsko. And I'm happy to give you this presentation on carbon farming and some of its aspects and new insights that we've got during the work on the carbon farming CE project, which you can see in the upper left corner, and which I will be talking about in detail later as well. So just for the beginning, let me start with a brief introduction of ourselves as an institution and of myself as myself. And here we go. So Agricultural Research Trobsko is a private research institution in Czech Republic. We focus on different agricultural aspects, mostly on pedology, anti-erosion measures, and also specifically on fodder species and cover crops, which are our main focus from the agriculture. We also have a department of phytopathology, so we have done some work in plant protection measures and techniques. And there is much more in specific points of view. For example, we also have this bumblebee breeding station. So we have bumblebees that we offer to farmers that have orchards, for example, for pollination and biodiversity enhancement. We work on national and international research projects such as carbon farming CE, but there is countless projects that you could see on our website if you go there. We produce seed of crop species that we breed in our institutions, especially the mentioned fodder and cover crop species. We collaborate with various companies on testing of their products, such as biostimulants or new fertilizers. And we also offer advisory services to farmers. My name is Štěpán Krejčí. I work in ART as a researcher in the Department of Agrotechnics. And as mentioned, I'm working on the carbon farming CE project together with my colleagues from the Agrotechnics department. that was just a brief overview of ourselves, and now we can get finally to the merit of our meeting, which is carbon farming. I will start with a general overview of carbon farming as a concept, and I will maybe you know some of this information already, but I will go through it in general to ensure that everyone is on the same page and that everyone has a good understanding of carbon farming as a whole. So what is carbon farming? The first question for those who haven't really got in contact with this idea. So basically, it's an agriculture approach or agriculture or way to do agriculture, way to do farming that is focused on carbon sequestration, on uptake of carbon from the atmosphere and putting it into soil where it can be stored. You can see a nice graphic on the right side of the screen. So basically, this is the pathway that we want to enhance and that we want to strengthen to the maximal extent. So there is carbon in the atmosphere in the form of carbon dioxide, as you've probably heard a million times. And the good thing is that it can be captured from the atmosphere by plants. It's a biotechnology that evolved on Earth during the evolution of species, and plants have this unique feature that they can pump out CO2 into their bodies by the process of photosynthesis, and in the later phases, we or farmers in particular have the possibility, have the capability of further work with this carbon that's stored in plant bodies. So in agriculture, there is a number of ways that can be utilized for the plant biomass to process and to bring the carbon in their bodies back into the soil. You can see some of these examples include composting or incorporation of post-harvest residues into the soil. Also, if we're talking about animal production, if this plant biomass is fed to the livestock, it can be later put back into soil in form of the manure of the waste products of the cattle. And one of the interesting ways to use the plant biomass to the maximal extent is also utilization of the digestate from biogas plants, which I will talk later in detail as well. What is important? While the main idea is to mitigate climate change and fight the greenhouse effect on Earth by decreasing the CO2 levels in the atmosphere, carbon farming has a very convenient side effects, let's say, of improving the soil quality and potentially lowering the costs for the farmers. It's important to know that there is quite a wide overlap with the regenerative agriculture, which is probably also known to you as well. Because while there are different motivations, because regenerative agriculture focuses by principle into improvement of soil quality and of soil properties, and carbon farming is more interested in carbon sequestration, the outcome is quite the same or very similar, because in the end we have a soil that's enriched by organic carbon, which brings many positive aspects to the soil health and to the soil quality and production as well. So just briefly about the underlying idea of the climate change, greenhouse effect, and the carbon dioxide concentrations in the atmosphere. You've probably heard this many times, but let me just repeat it for you. We have increasing concentration of carbon dioxide in the atmosphere. That, among others, causes the greenhouse effect. We can imagine it as CO2 forming a sort of invisible layer in the atmosphere, invisible wall, like the glass wall of the greenhouse, that deflects the heat escaping from the Earth's surface back to the surface. you probably saw the illustrations to this. Anyway, the outcome is the eventual trapping of the heat in the Earth's atmosphere and the warming of the surface. To illustrate this statement, please see the figure on the right, where you can see the correlation of mean temperatures on the upper side of the figure and the concentrations of carbon dioxide in the atmosphere on the lower side of the figure in the past 100,000 years. These data are taken from the European Environment Agency, and they are obtained from the Antarctic or polar regions ice, which conserve the atmosphere contents and atmosphere distribution of gases from these ancient times, and the temperature is probably a result of modeling. Anyway, what's important also is that by now we are having like more than 400 ppm of CO2 in our atmosphere, and as you can see from the figure, this is quite addressing one of the common arguments that are sort of speaking against climate change and this climate awareness or climate alarmism, that there's been always this fluctuation of CO2 levels in the history. It's true, you can see it in the figure, but if you take a closer look, you can also see that in the peaks of this figure, in the maximal levels of CO2, the values have never really exceeded 300 ppm. Now we are way over that, and this quite illustrates well that it's not just a natural cycle, that it's really influenced by the human activity to a large extent. What's important, the global warming has the potential, and it actually does it, we can see it also in some cases, has the potential to disturb the ecosystems and the weather cycles that are also influencing the ecosystems, which can lead to weather extremes, and basically this disturbing of the ecosystems leads to imbalance, which means that some species might go extinct, some species as pests, for example, might overpopulate, and there might be epidemics of this pest outbreaks and so on. So all of these are facts that are very bad for agriculture and for plant production and production in turn as well, of course. A good example of a greenhouse effect that we can see in the solar system is Venus, where there's a lot of greenhouse gases in the atmosphere, and as a result of that, there is a huge, there is very high temperature and pressure on the surface of Venus, which makes any life in there in the way that we know it from Earth impossible. And what I'm trying to say is that we don't want to have situation like this on Earth as well in a couple 100 years or something. What's a good thing, what's a good message is that while in the atmosphere we don't want the carbon because it causes trouble, we do want it in the soil in turn, because having carbon in soil means a lot of positive features, positive characteristics, positive results. Carbon in the soil, organic carbon, turns into humus by time, and humus content in the soil is very good thing because it has the potential to improve the physical structure of the soil, to increase the aeration, increase the water holding capacity, increases the capacity of nutrients that can be stored in the soil and that can be readily used by the plants. And it also supports the thriving of soil organisms, microorganisms like bacteria, fungi, but also macroorganisms like worms or moles, for example, that also enhance the nutrient cycle and can in turn help the plants to grow faster and better. Here is a sort of classification of soils according to the humus that they have in them. So if the humus content is below 1% or below 2%, these soils are not really very fertile. They are not very quality ones in terms of humus content. But since like 2% up, it gets better, and it has very much like a visible result. For example, in Ukraine, as one of the most productive areas of Europe in terms of agriculture, big proportion of the soil have humus content over 9%. So you can see how that really helps in practice. Oh yes, sorry, I was talking in advance. So here you can see this sort of division, and we can move forward. We've been talking about carbon farming, but we've been talking about what it is, what it has, how much potential it has, and so on. Now let's take a look about the specific techniques that make up the carbon farming. So we have two groups of techniques, those that increase the capture of carbon from the atmosphere, and those that help to keep the carbon, the humus, the organic carbon in the soil. Because thanks to natural cycles, the organic carbon that is stored in the soil can also escape the soil and can be turned back into carbon dioxide by microbial activity, and that's what we want to minimize, so that we maximize the actual content, the stable content of carbon in the soil. So the techniques that mostly enhance the carbon sequestration are organic fertilizing. If you apply the organic matter straight into the soil, it naturally increases its content. It can be compost, manure, those that I mentioned before. Then we have cover crops, which also basically bring another organic matter into the soil when the cover crops are incorporated after their termination. And techniques that's specific for carbon farming is agroforestry. For example, for organic fertilizing cover crops, they also are present in regenerative agriculture. Agroforestry is more carbon farming focused because its main benefit is the long-term storage of the carbon in the biomass of the trees in the wood. It stays there for decades, even thousands of years in some cases. So that's desirable from the sequestration point of view. And then we have some of the techniques that increase the retention of the carbon in the soil and that limit the desequestration. Here, the most important one is probably tillage reduction, which lowers the aeration of the soil and thus slows down the microbial activity and the subsequent decomposition of humus. Also important is soil covering, basically mulching, but here I also have the cover crops mentioned because they also have this function when they are growing, and when they are sometimes the cover crops, when they are terminated, they are basically mulched over the field, and they also have this soil covering function. It prevents desiccation, again limits the aeration and humus decomposition. What are the benefits of the carbon farming? Once you have a stable, adjusted, and long-term practiced carbon farming practice on your farm, there is the increased, sometimes even significantly increased carbon content in the soil in the form of humus, which brings all these benefits that I mentioned previously. And from the practical point of view, it can also bring reduction of costs because less fertilizer is needed, and it also is better for the environment because there's less nutrient leaching into the lower waters, and again, you can save some money on the fertilizers. Soil coverage limits erosion and also improves the water regime of the field. Tillage reductions is also a way how to save money, because apparently the less inputs, the less agri technical operations you put in, the less fuel you consume, the longer your machinery persists before it needs to be replaced. You have less work basically because you don't have to go to the field as often, and also there's less subsoil compaction, of course, and this is also a thing that has many other outcomes subsequent. As I said, if you have a stronger microbiome in the soil, the nutrient cycle is faster. Also, generally stronger ecosystems that are more diverse are more resilient towards the climate change and towards the weather extremes. You can imagine that if you have the food chain and there is one species of the primary production, which is on the beginning of the on the chain, and it struggles because of the weather, the whole chain will be affected. But if you have 3 different species on the bottom line of the food chain, and one of them struggles, the other 2 can basically make up for that, and they can cover the need of the further parts of the food chain. And thus the whole chain will be not as much as affected as the one that has lower biodiversity, for example. So these were the positive aspects. Now we're quite getting to the price of carbon farming, as was mentioned in the beginning, because these are good things, of course, but there are also the bad things about it. And for farmers who are living of their work on the field, these are crucial, and these are often the reason that they don't really practice carbon farming too much, especially in Europe. The thing is that in the beginning, you will need new machinery, you will need new devices, new gadgets. This will bring large initial costs to get equipped. Also, organic fertilizers are not exactly cheap if you don't produce them yourself, if you have to buy them. And for example, cover crops, they bring additional costs by each step of their implementation. Basically, you have to buy the seeds, you have to sow them, and you have to care for them. So these are extra costs, extra operations that you have to perform. What is also not as convenient is that the positive changes that I was talking about, they really take time to take action. The buildup of the humus is rather a long-term process. It takes 5 or even more years to be detectable, to be visible. On the other hand, the negative aspects that are known to happen basically every time they take action fast. They happen fast. The most important, the most problematic is the drop in the yields in the first years of the shift to carbon farming, of this transition. Especially in some techniques like the reduction, these are causing this effect a lot. The decreases might be even significant. You will see it in one of the case studies I have prepared for you in the later slides. And it's also quite a delicate, complex system in the soil. So it really needs to be adjusted carefully and managed smartly so that everything works and everything is right in the place and the system is well balanced in all the steps. Anyway, it's like that. We know it, and we have to take it in account when we are advising farmers to set their way in this. What I would like to mention in here as well is that there are these costs, but in the end, when you overcome this couple of the first years, then you will get to this part where you will only yield the benefits. And in the long term, in average, we believe that the outcomes and even the stable yields will be either comparable or better than in the conventional agriculture. And if we have comparable results, we need to keep in mind that there still would be the lower costs. So technically, your income would be still higher. Anyway, the last thing that I have. The last thing that I have in the general overview is the carbon credits, which is a topic that's quite controversial. We have met this in person. We have talked to people that were very skeptical towards it. We understand it even because the business is quite complicated, questionable on some terms. It's not finely tuned. It's still in a sort of initial phase of forming. So there are some uncertainties, some things that need to be addressed yet. Anyway, the idea is that the farmer that practices carbon farming produces the carbon credit by sequestrating the carbon from atmosphere to the soil. So basically, each ton of carbon dioxide stored in your field as a farmer counts as one carbon credit. And then they sell these carbon credits to companies who trade them to other companies, to any companies on the market who might want to buy the carbon credits to declare their climatic responsibility and that they want to compensate for their carbon footprint and so on. It's a bit abstract, maybe, let's say. As I said, there are some uncertainties on different steps on the process and the trustworthiness of the carbon credit trading companies and the initial phase, if the sequestration really occurred as it states it did. On the other hand, if you want to do carbon farming and you have no experience, it's important to notice that these companies, the carbon credit traders, they usually offer sort of advisory, sort of tutorship to the farmers so that they do the sequestration correctly and that they can produce the carbon credit. So it's a way how to get, let's say, free advisory. And in the end, if you want to do it, it's probably not good to do it for the money from the carbon credits. But if you want to do it for your beliefs, for the climate, for your own economical dedication, then it might pose as an extra income. And any money that you can get for what you'd be doing anyway, I think it might be interesting for the farmers as well. Okay, here we have two case studies from the world that illustrate the long-term effect of the carbon farming. Here I want to show this particular study from Switzerland is especially valuable because it shows the stabilization of the yields in the long term. I will get to that. So anyway, what we have here is a study from Switzerland on light sandy loam soils, and there was a no-till system combined with cover crops. Some of the experiments took up to 20 years, the longest ones, but the good thing is that there is a gradient of different durations, and that's a good thing. I will show you on the left figure. What was the results? We can say that in the long term, the yields were stabilized or even slightly increased, and there was a buildup of the soil organic carbon in the upper part of the field of the soil. You can see it on the right. This figure shows that in the top 10 centimeters of the soil profile, there is a very significant increase of soil organic carbon and also of the total nitrogen. Basically, it's you can see it in this upper part. This is the control, the conventional agriculture, and this darker curve is the conventional is the no-till system. So you can see in the top 10 here it starts to diverge, and in the top, let's say, 5 centimeters, we have like nearly twice as much organic carbon. What I wanted to speak about was the long-term effect. You can see on different crops in here. This is the number of years that the experiment was going on. You can see that in those that were cultivated in the no-till system for 20 years, you have this column is basically the yield of the no-tillage areas against the conventional areas. So this is like the percentage of the yield from the no-till system in comparison to the conventional. So winter barley, for example, in the 20 years experiment showed 106, nearly 106% of the production of the conventional area. you can see that it really works well in this longer term, and it also differs with different crops. So for example, for the peas or for the beans, for the leguminous species, the increase was there even, and quite significant increase in just 6 or 8 years. On the other hand, or even 5 years in here with the winter peas. What we can see as well, that there are these crops that have been cultivated for a year or two in the no-till system, and as I suggested before, you can see that there is quite a significant drop in some cases, not in the case of the wheat, but for example, with the winter beans or with the soybean, you can see that there were up to 20% decrease in yield. Okay, this is one of the case studies. Another one is from the USA, from Ohio. This is even more robust experiment because it's been going on for nearly 50 years. There were two sites, two different locations. One of them had sandy loam soil, so lighter soils. That was the Worcester location that you can see in the figures. And then there is the rather medium or heavy soils, clay loams on the Hoytville location. The conclusions show that there were quite slight differences in the yields. So again, you're not getting, in this case, you're not getting higher yields, but we have to keep in mind that you are saving money on the agriculture operations, on the machinery operations. Soil structure was improved, water capacity was enhanced in the no-tillage system, and also there was the visible organic carbon buildup in the soil. So what you can see here, I will just briefly comment on the figures. The PT is the conventional system. MT is like reduction of tillage, but still some level of tillage was there. And also, yes, NT is the no-till system, so there was no tillage, and WL is control, basically. It's undisturbed soil in the forest. What you can see is the soil organic carbon that's gradually building up from the conventional towards the no-till or the undisturbed system. This is average of several years, I think 4 or 5 years maybe. Yes, here we go. Here it's written. Here it's the same, I think. And you can see that basically in 5 years we're getting rather close to the undisturbed soil profile, especially in the upper parts of the soil profile. In the Hoytville region, the trend is similar, but you can see that there we have much higher organic carbon content in the undisturbed soils, which is not as relevant for our purposes anyway. Then there is the yield aspect, which is important for farmers in the first place, probably. As I said, you can see that there are no big differences between the various approaches, and that applies for both of the locations. We can even see that there is the best result for the medium way to do it, for the reduction tillage, not for the no-till. And there is the available water content, which you can see is also enhanced in the no-till system and in the reduced tillage system. You can see, for example, in here, yes, there is basically a gradient. It's gradually improving with the level of the reduction of tillage. So anyway, these were examples from the world, but you can see that this is a very actual research topic. I think it's best illustrated by the very pleasing number of participants of this seminar today. And at this point, there are two European projects focused on carbon farming. One is Carbon for Soil Quality, which is focused on the Mediterranean area, and then there is the Carbon Farming CE project that we've been working on as an institution that is focusing on the broader area of Central Europe. Some farmers consider it already at this point, as of what we've talked with them in the Czech Republic, especially, consider this as an inevitable way for the agriculture to develop in the recent years. And it's good to mention that we are a bit getting behind compared to the world as a Europe, because I think this has been focusing solely on the no-tillage systems. But the thing is that in Europe, around 1% of arable land is managed with no-till systems. In contrast, in Australia, it's more than 10%. I think it was 11% of the total arable land. In the Americas, it's been even higher. In Southern America, it's been like 30%. So that's a huge difference. And we can see that it works in the world, and that it could as well work in Europe if we really got to it, and if we were dedicated and motivated enough, or we, the farmers, especially our European farmers. What is important to mention, the carbon cycle is very specific. It's very sensitive towards the climatic conditions, especially to temperature, to moisture, to basically the water availability. And for this reason, it's really important to conduct the studies that we can use as arguments to persuade the farmers to do their practice this way. It's really important to get the data and the measurements and the experiments for the specific locations to be very sure that there is no difference. Also, we need to keep in mind that the dynamics of the change is slow, and thus we need really long-term experiments and robust data to have really a good idea about the actual costs and outcomes. Okay, here I'm getting to the carbon farming CE project. I'm getting a bit behind on the time, so I will just very briefly run through this. Carbon Farming CE is an international Interreg project for 3 years. It's finished in this month. Actually, by the end of March, we're finishing. We have tested these carbon farming techniques that are listed in here, and then we have formed cooperation models that aim to bring the carbon farming in the agricultural practice to a larger extent. Under this QR code, you can find the official project website. So if you're interested, please scan them. And here I have some of the results. This has been, I have the results that we have obtained ourselves as an institution. So very, very fastly. There is a surficial compost application. I will get to this later in better detail. So just briefly, you can see that there has been some buildup of the total organic carbon in the soil. It's been just one season, okay? So it's really more like illustrative results, but you can see that some changes occurred. And this is important. This is a measure of the quality of humus. The higher this ratio is, humic acids to fulvic acids, the more stable the humus is, and the longer it will stay in the soil, the slower it will take for it to decompose and to turn back into atmosphere. So you can see this is quite a good result. It's quite a large growth. Then we have the tillage reduction. This is more like, you can see in here that it didn't really work the way we hoped. The total organic carbon in the soil increased in the control and decreased in the no-till system. So very opposite to what we would expect, what we would hope for. The explanation for this is that it was, again, just 1 year experiment. And as I mentioned, in the short term, it doesn't even occur sometimes. And the seasonal fluctuations that are also part of the natural cycle might overweight the long-term effect. And we can't really see the long-term effect in the 1 year cultivation. So this is another proof that we need long-term studies to have trustworthy results. Then we had this mulching experiments where we applied the fresh biomass of fodder caliga on the field, and we again watched the total organic carbon buildup. You can see that there is quite a nice result in this. There's been quite some increase in the total organic carbon in the mulched fields. Then I have 2 other results from our colleagues from the project. This is from Croatian experiments from our Croatian colleagues, where they did the mulching with alfalfa biomass that they also applied surficially on on the field where corn was cultivated. They have tested 2 different dosages, either 70 cubic meters per hectare or 140 cubic meters per hectare, and they have applied them in 2 rounds. No, they have took the application was in May, and the initial and terminal analysis of the soil were conducted in April and September. They also evaluated the humus and the total organic carbon in the field. You can see that there has been quite nice humus buildup in the higher dosage system, and also the total organic carbon buildup in the lower one, or basically in both of them it worked. What is important, what is interesting, the Croatian colleagues did some extra work, and they also inspected the microbial colonization of the soil samples. So you can see that the application of the mulch very much enhanced the bacterial colonies. So in the control, there's been this deep drop of the bacterial presence in the soil, but if the mulch was applied, you can see in the higher dosage that there's been a huge growth of bacterial activity, which is a good thing. Then we have this agroforestry experiment. It's an interesting approach because it's not really the conventional way to, or it's not the common way to do agroforestry. In this case, the colleagues from Poland have worked with a very unproductive, poor soil, which was used for cattle grazing. So it was a silvopastoral system. What they did was that they didn't cultivate the trees for many years, but they instead just sowed the trees as very young ones, and they let the cattle to graze on the annual tree sprouts directly. So basically the trees were not there for years, but they served as an alternative biomass for the fodder. And you can see this is the control, this is the grassland that was there before, and you can see that this is the this is the fresh weight biomass, this is the dry weight biomass. You can see that the control and some of the trend species, especially Karagana, which is the one you can see in this picture, a leguminous tree, or mulberry, had very similar or even higher production than the original grass cultures. As I said, we have moved to the collaboration models or cooperation models in the latter phase of the project. I will probably skip this a bit because we're running out of time, and I will get to the carbon farming relevant studies that our institution has worked on in the recent years. I have 2 examples for you with the economical analysis. So here we're getting back to the prices again. And we have 2 different forms of organic matter applied on the field. First was application of compost without incorporation. This was basically a double effect technique, because first we applied organic matter, the compost. So it was an organic fertilizer. We added organic matter to the soil, but at the same time, it wasn't incorporated in the soil. It stayed on the surface. So basically, we also obtained this mulching effect, just not with fresh biomass, but instead with the compost. Important aspects that we need to take into account with the compost when we use it is the quality of the compost. There are several measures to follow. One is the carbon to nitrogen ratio in the compost, which ideally should be between 20 and 30. It should be humid to between 40 to 65%, and it should be matured. It should be processed for at least 1,180 days. And you can say that the compost is ready when the inner temperature drops below 40 degrees Celsius on a stable time scale. The experiment we have conducted was going on for 3 years between 2022 and 2023, and we have practiced 3 experimental sites with loamy soils and different application doses and different compost, because the important thing in this case was to use the locally available resources, as you will see later. So in the first location, there was 30 tons per hectare dose of compost applied. The soil type was candy soil, so you see it's more like a medium heavy soil as the other ones, although probably a bit heavier than Chernozem in the last location. You can see that the CN ratios were not optimal in any case, but again, it was very important to secure the nearby local source of the compost, and the compost plants that offered us the compost at the experimental sites just had this quality, and you just have to take it into account. You can also see that the total nitrogen content in the different compost types varied greatly, especially between the first and the last experimental site. So you can see that there's the same dosage, but a very much different actual dosage of nitrogen in them. In the second location, there was a much higher dosage of 200 tons per hectare, and the least quality compost used, in fact. So here are some of the results, some soil data that were obtained on the end of the experiment. Each of the locations have the control where the compost was not applied, and the compost treatment where it was applied according to the previous descriptions. You can see that in most cases there was either slight here and here, or quite significant buildup of the organic carbon. So that was nice. What was quite surprising was that the stability, the quality of the organic matter wasn't really as convenient as the total organic carbon. You can see that in the first two locations, the stability was not as good. This might be probably attributed to the lower quality of the used compost. But in the case of the last location, in the third location, you can see that there was the positive change also, and quite significantly positive change also in the quality of the humus, which is attributed to the better quality of the used compost. Then also the contents of the three most important macronutrients were evaluated, so you can see that they either didn't vary too much, or they had some positive effect as well. Here we're getting to the economical aspect, which is one of the key points. What were our findings, our calculations? The dosage had to be lower than 100 tons per hectare to be economically reasonable, to be economically feasible, to be beneficial. And what's the most important thing is that you need to get the compost from local resources. The transport range is one of the most important aspects of the economical feasibility of the process. Basically, the composting plants needs to be in the range of 2 to 12 kilometers from the site of usage. These are data that were obtained for specific Czech conditions, Czech prices, and so on, but they are illustrative of how it worked in our case. Also, of course, important is the quality of the compost. You have seen it in the result table, and we have also concluded that not the lack of incorporation of the compost into the soil can bring 20 to 30% save of costs in comparison to the situation where you incorporate the compost into the soil. And also there is the beneficial extra effect of mulching that you don't get when you incorporate the compost into the soil. There is a cost analysis table. It shows that different combination of transport distance, which is the first line on the axis, and the dosage on the second line, brings different costs. Unfortunately, the values are in Czech crowns. It was not really feasible to rework the whole figure. Anyway, you can see that especially in the highest dosage of 200, the costs are really rising steeply. And it's also important to see that the difference is mostly created by the blue segment, which is the transportation cost. And there we're getting back to the idea that the resources really need to be as close as possible to the site of usage. You can see that this is what makes up for the difference in, you have the different transport distances, 2, 4, and 6 kilometers. And you can see that only in 6 kilometers, the difference is like 1/3 compared to so it's basically it's directly reflecting the transportation size, transportation distance. Another topic, another experiment that we've done was digestate application. This is a very interesting thing that is not as much widespread yet as a fertilizer, usage of digestate as a fertilizer. So digestate, what it is, it's a waste product from the biogas plants. Waste is purposefully written like this because if you look at it as a fertilizer, it's not a waste in the end, but it's a valuable resource. In fact, it's good. Good thing of it is also that it contributes to the circular economy concept because you're using waste products for another purpose and you're giving them a new purpose. It basically consists of two fractions, solid and liquid component. The solid fraction contains some organic matter, which is good for the soil, as was discussed earlier, and the liquid fraction contains a lot of ammonia, nitrogen, so it brings a lot of available nitrogen that can be readily used by the plants for fast utilization. In Europe, there is annually produced around 130 million of tons of digestate. In Czech Republic, it's like 8 million tons, I think. What is important to notice or to mention is that digestate has these pros, but it also has some cons. Basically, it's quite unstable or low quality organic matter, and it can be easily turned into gas ammonia and desequestrated into the atmosphere. It can also leach into the environment and pollute the lower waters, the underground waters. So it has to really be managed very carefully and very professionally. Because of the instability, it's desirable, as we concluded from our experiment, to accompany the digestate with fresh organic biomass, and it has to be incorporated very fast, ideally until 12 hours since the application. Another of the positive aspects is that it's very cheap, as you will see in the next slide. Basically, here are some of the experiment overviews. So it's been a 4-year experiment. There have been 3 treatments. In the control, no digestate was applied. In the first experimental treatment, it was applied once in 2 years, and in the second, it was applied in each year. The dosage was always 20 tons per hectare. What we marked was increased yields, as you can see in this table in here. Basically, in the highest application rate every year, you can see the highest yields in each year with each of the different crops. And it also, which is not presented here, but it also brought higher stability of the soil aggregates. It helped the organic carbon buildup and humus buildup, and it also slightly increased phosphorus and potassium content in the soil. Economical aspect, as I mentioned, digestate is cheap. On the other hand, the application is more expensive than the application of mineral nitrogen, but this one is more expensive as a substrate in turn. What we did was comparison of the equivalent nitrogen dosage from the digestate and from respective amount of mineral nitrogen fertilizer per hectare. So for digestate, 1 ton of digestate costs like 6 to 8 euros, really. So it's very cheap. For considering the dosage of 20 tons per hectare that we used, it brings us to you can calculate it, right? It's like how much is this? Well, anyway, combined with the transportation and application costs, if we consider 5 kilometer range from the biogas station to the field, the application and transportation costs would be 32 to 60 euros per hectare. So per hectare, in sum, you can get to 152 or from 152 to 220 euros per hectare, the amount that you have to pay, the amount of money you have to pay for digestate application. Important to notice is that we have calculated 5-kilometer range of transportation, and that's a crucial aspect, as you have seen in the previous experiment as well. So this is a variable that has to be carefully taken into account. On the other hand, if we have mineral nitrogen, the application costs are very low. It's like 20 euros. On the other hand, the price of the fertilizer itself, of the analogous amount to the digestate nitrogen, would be 420 to 460 euros. So in total, you would get to the price of 440 to 480 euros per hectare. And you can see that this is more than twice as much than in case of digestate. Of course, it's easier. It's not as risky or not as complicated as the digestate application. It's conventional, but you can see that the potential for the cost cutting is very significant. This is basically the end. Here I have a QR code for a short questionnaire. I would ask you to please scan it with your phones or screenshot it and fill it out later. Anyway, if you're interested in more information, in any sort of consultations from our side, or if you're interested in any future projects on carbon farming or related aspects, and you would like to collaborate with us, please don't hesitate to fill in the questionnaire, leave us your email, and we can see if we can come up to any collaboration in the future or any further help to you if you're interested. Thank you for your attention. Here are the references for the case studies I have used, and thank you for your attention. Hope I left some time for the discussion as well, and if you have any questions, I'll be happy to answer.
Yeah, hi again. While you were presenting, thank you. There is a lot of questions have risen, so there are two possibilities. Either those who put the questions, you can come up and ask them face to face and have a discussion, or I can just read them. So if you want to, so please just turn your cameras on and start speaking. But I will start with, I guess I will start with the latest question. Is the digestate application experiment, in the digestate application experiment, did you measure also the content of pollutants in the soil after application? For example, increase in microplastic content and or changes in the microbial communities?
We have not, but it's a very good notice that I didn't mention in the presentation. But of course, it's another concern while working with the digestate. It's really important to take into account that the quality of the digestate, including these pollutants or microplastics, is very dependent of the organic matter that's been put into the biogas station in the first place. And this is also a thing that should be taken care for before you start, so that you don't really induce undesirable substances in your field. Of course, yes, that's good. It's a good thing that you mentioned this. We haven't really checked the microbial community's response to the technique.
Mm-hmm. Yeah, then there is some already discussion going on about is it true that no-till is not suitable for all plants, for example, corn and potatoes, and there is also already some discussion on it, that no-till is complicated in potato production, because even if you plant the seed potatoes without tillage, it's difficult to harvest without disturbing the soil. And that in Sweden, the trials so far indicate that the carbon content rather shifts toward 0 to 15 centimeters with no-till, reduced till, and increase in total. So Malin, if you have some additional comments, we would be happy to hear that. Štěpán, do you have anything to say about this?
Sure. If Marin wants to start with some further comments, I will give her the space. Otherwise, I can start. Yes.
I just want to thank you for a very interesting presentation, and I don't think I have anything to add. It was not so much. It was another question about why the spread of these practices is so low compared to when there's so many, and I think that maybe these contrasting results in different parts and in different climates can be reducing the implementation of the practices.
Yes. Okay. I will start with this last note or question. It's of course it would be of course interesting to dig deeper and to see what's the underlying results. In some of the countries, it might as well be that for example, the agro technique or the machinery is not as available, or the fields are larger. Could be the reason that some of them are not tilled, not because they would want to, but because they don't have the capacity. Maybe I'm just thinking. I don't have idea, but could be this. Also for Australia, this is, for example, a good case where the climate is much harsher and much more less convenient for agriculture than in Europe, for example. But that brings the need to experiment further and to give it extra attention and to try things that are exactly increasing the resilience of the system towards the weather extremes. And in the end, maybe it's also a bit of a historical thing. It's also good to understand that many of these techniques that I mentioned before, like organic fertilizing in the first place, it's not something completely new. It's been there in the history. It's been there in the past. People have done it for centuries before mineral fertilizers were invented or introduced. Actually, the thing is that in the previous century, let's say 100 years ago, or something like this, when the mineral fertilizers were induced, it really it's easier, right? But the negative aspects, like the soil disturbance and the soil exhaustion, these were not really understood. These were not known. And now that we understand that this is happening, it's more about finding a balance that's as productive as can be and as conservative as can be in terms of soil conservation and sustainability. Then, if I get to the questions that you put in the chat, of course, in case of potatoes, it's probably going to be problematic, as well as we can say that to some point it might be crop specific, at least in the case of the subsoil crops like potatoes or sweet potatoes or manioc or whatever like this. What is also important, which I'm not sure that I stressed out enough, was that it also depends on the soil type. So as we could see this to some point in the case study from the USA, from Ohio, that there were slightly different results for the two soils, and it's probably more complicated it takes longer, and it might be not as stressed for the positive changes in the case of heavier soils. So if we have light sandy soils, there's much higher potential for improvement with the carbon farming techniques probably, and there we're getting to Australia again, where this is quite the case as far as I know. And the last question you have in there about it's true that basically the carbon content is built up fastest manner in the upper 10-15 centimeters, but you can see this in the I would again refer to the study from the USA. Maybe I'm not sure. You can probably still see my screen, right?
Yes, we can.
So let me just get to the yeah, okay, now it's working. Let me just get to the case study from the Americas. Yes, here. Yeah, so you can see that for example, the organic carbon buildup has been strongest in the upper soil layer, but it's also present in 2 to 20, not as much in 20 to 30. Yes, you can see in here, especially in the no-till system, and even lower. But as I said, it really takes time, and it's also important to notice that. Especially for where do I get back to? Yeah, here. It's also important to notice that these techniques that are focused on carbon sequestration and retention really speed up the process a lot. So the natural cycles, they take much more time. Basically, just what we can achieve with the specific carbon farming techniques in let's say 10 years might take 50 years in the natural systems. Only there is not the takeaway of the nutrients and the organic carbon by the agriculture processed in there or practiced in there. But honestly, I haven't seen these trials that you mentioned. So again, could be that it differs in different conditions, different locations, and it supports what I said earlier, that it's really important to have specific data for a specific location, because what works in one part of the world might not work in another one, and we need to know so that we are accurate. If that's enough of answer. Hello, can you hear me?
Oh, okay. Sorry, I have no noise and no sound. Sorry. So we are a lot over the time, but I would say we have two groups of questions still. Maybe we can go quickly through them. Silke is asking what type of compost was used in your experiment. The question came quite early, but and after you told about some of the compost you were using, but maybe you can specify on that.
I have to admit, I'm not really sure how to answer the question. I don't know too well, honestly, this detail. What I can say is that they were used from local compost plants that differed in their compost, as you can see from some of the parameters of the compost. But if the question aims at what sort of substrate was used for the compost preparation, I don't know. Unfortunately, I'm sorry. I don't have an answer for that.
Mm-hmm. And then there is a series of questions about carbon credit certification. Like I will just read all of them, and then you can answer. So one of them is regarding carbon credits. How can they be validated? Then, does anyone know of any successful carbon credit certification cases in the EU? And also, what are the biggest barriers today for farmers to engage with carbon farming? Technical complexity, uncertainty of payments, lack of advisory support, and that many projects are generating this knowledge on carbon farming, but adoption remains limited. What do you think is still missing to move from pilots and projects to large-scale implementation? So yeah, basically it's a bunch of questions.
Yes. So about the carbon credits, it's and the certification. This is a thing that was sort of new to us. We have learned about this during the project mostly. We have had literally an exhausting session with a representative of one of these companies, and he was giving us an overview about how the system works, how it's supposed to work, and he also mentioned the certification. This is what I meant when I said that there's a lot of uncertainties, a lot of mess, if I can say it like this, in this area, because as far as I understood, and honestly I'm not sure I understood correctly or in the whole, is that you have the carbon credit trader who, in collaboration with the farmer, produces the carbon credit, but it needs to be certified by a certification authority, by another company, organization, institution that has the right or the capability of giving out authorizations and certifications. Honestly, this has been an issue with the largest carbon credit trading company in Czech Republic. I know that they have struggled with this, that it took time, that there were some uncertainties. It's also a problem that there are not as strong supervision capacities or capabilities around the world. So if we'd like to merge the carbon credit markets with the rest of the world and not just limited to Europe, then we would need reliable, trustworthy certification authority that could take action in South America, in Africa, and this is a huge task, and I can see that there would be a huge difficulty in this, for example. So the certification is of a trouble. Also, what I learned is that if technically a company, which was also surprising to me, for example, if a company buys carbon credits and they are not certified, and it turns out that they have been fake, let's say, or that they have been not really, that the carbon has not really been sequestered with this carbon credit, the company that bought them is supposed to pay a fine. And I don't really understand, why is it the company, why is it not the carbon credit trader that has the highest profit on this business model? And that, in my opinion, should be responsible for securing of the trustworthiness of the credit. But this is what it is. So as I said, even for me, it was quite baffling at points, this carbon credit system. It's, if you're deeply interested in the topic, it's probably the best to get in touch with very much the carbon credit traders, because I have some understanding, but I might not have all the information or the very best idea. What I also would like to mention is that for some, and in this part, I'm getting to another question that was part of this that you mentioned in this place, was that some of the highest or the worst obstacles for the farmers to start with carbon farming would be some of the practical ones. As I mentioned, the costs, and this is really a thing. Like in Europe, the farmers really have struggled with the profitability, the small scale farmers especially, and buying new machinery. And it's not just one tractor. It's basically you need new machinery for sowing, for the reduced tillage. You need new machinery for harvest and for other, for example, the organic fertilizers. You need specific machinery to be able to apply the compost or the digestate, and so it's a lot of machinery that you would need to get, and this is for many farmers just unfeasible. Then it also, I would say, another great problem is the lack of belief of the farmers into this concept, and that they don't want to experiment with their means of living. I mean, as I said, they are dependent on their carbon farming practice, on their farming practice, and if there is a consequent and repeating drop in yields for 5 years, and they have 20% less yields, it can be detrimental for them. It can be really like not possible for them to go through this. So this is another problem. And in the third place, in the last place, there is this controversy, and this is an unlucky thing. This is an unfortunate thing for many of the farmers. Once you say carbon farming, what they hear is carbon credits. And as we discussed, it's a bit shady business sometimes. It's a bit abstract, untransparent. People don't trust it. There is this sort of controversy among the farmers. And if you say carbon farming, they hear carbon credits, and then they say no, we don't want to deal with this. Good thing to realize is that it doesn't have to be you can do carbon farming without pursuing carbon credits, and that's what I would say is like something that we might want to pass to the farmers, that we might to stress out and explain to them that they don't want to do it to get some carbon credits, which are controversial, but that they might want to do carbon farming because in long term it might bring actual benefit to them: stable yields, healthy soil, and lower costs for their practice.
Yeah, thank you. Oh God, this was a long session of coffee break. Thank you, Štěpán, for your presentation, for your insights, and thank you for all the active question givers and listeners, and thanks for your attention and overtime here. So I really hope you can use it in your future job, which is the main idea of coffee breaks, to be speaking about themes that are very practical, and I think this was one of them. So yeah, thank you all for participation, and see you next time. Bye.